Hello everyone, welcome back to our modern operating system and computer network. So myself Dr. Madhibanandurai, currently working as an assistant professor to the Department of School of Computer Science and Artificial Intelligence in SR University at Warangal. So today discussion is based on this error detection and correction. So in the last lecture, we slightly discussed about this error detection and correction. In that the today discussion we will deeply discuss about this how error will be identified and we need to how to sort out the corrections by using the methods we will discuss in deeply. Let's go to the section. So coming to the error detection techniques, there are three methods. So first we need to understand why we need to detect the errors. So from sender side to receiver side, while transferring the data, it should be more reliable while transferring data. It should not be any error occur or flipping the data or any uh, errors occurs in meantime while transferring that one. We need to identify how we need to identify by checking the data. How we can checking the data by using a three methods. One is sorry, four method. We have to use the four methods to use the checking the error methods or error detections. So generally, to detect the errors, a common techniques is used to introduce a redundancy bit that provides additional informations. So while transferring the data one to another or one node to another, we will adding an extra bit by it we called as a redundancy bit. So how we can add the redundancy bit? What basis we can add the redundancy bit? So we will discuss one by one. So the first one is a simple parity check. Second one is a two-dimensional parity check. And third one is a checksum method. And finally, cycle redundancy check methods. Coming to the simple parity check method. So the simple parity method is an error reduction method that involves adding an extra bit to the data while transmitting one to another. What basis we will adding an extra bit, the redundancy bit is based on the we need to count the sum of ones appear into the data. For examples, here from the center side, we can see there is an 4, 2, 4, and 6. 8 bits data are appeared here. From that 8 bits, we need to count how much ones are appear into the data. For example, you need to count here 1, 2, and 3. 3 ones are appear into the data. So which means this is an odd number. So while getting an odd number, we need to add it as a one more add number to make it as an even digits or even datas at the end of a receiver side while calculating at the end of receiver side. So in case of your data should be is in the even number, we will directly put it as in a zero. So here is the initial stage of data. So we need to compute the parity bits we directly take from here like a 1000 and double one, and at the end of the data we need to add as a one because of the sum of ones are in it is in the odd numbers, so we will directly add it as a one to make it as a even. So before going to transmit the data we have to do it like this. Then at the end of receiver side we will check it once again at the end of receiver side, so whether the number it's appearing or received is an even data bits. While counting the sums of one, the data should be more reliable and acceptable. In case of it is not in the even number, so it should be rejected, and further we need to send the notification to the sender side to recheck the data and send it again to the receiver side. So yes, sorry. So coming to this order even, there is a two category. Maybe in the upcoming section I will discuss. So here we will following as a if we will get as a sum of ones in being sum of ones as being as odd, we will make it as a even. So another cases also be there. In case of sum of one should be even, we will use it as a one to make it as a odd methods also. So there are two categories are used for the checking methods. But in this case, here we directly use it as a even method. So coming to the even method, in case of sum of ones should be in odd, we will use it as a we will convert it into the even paradise. So even paradise bits. So why we need to these kind of things, these kind of methods to identify the error while transferring the data one to another. So where this is one of the very simplest method in the error detection methods, and more efficient also to use the identify to identify the errors in the data transmissions. Coming to the next two-dimensional parity check. So coming to the two-dimensional parity check, so this is the sum of data bits are appeared with the different sets like a one, two, three. There are four set of data are appeared. So two-dimensional parity checks bits are calculated for each rows. So the data should be aligned as a each rows. Like in the each rows, we need to make it as a sums of paradises. Same like it quite similar to the simplest method. So here also we need to uh, count number of ones in the each categories. For example, here is a four ones are appeared. So which means even numbers appear. So we directly use put it as a zero because we the process we will use a even parity bits even parity check methods. So in those cases we directly add it as a zero. So in the second row is also same like we need to count the how many number ones are appear into the in that category or bits like four ones are appear, so which means a even number, so directly put the zeros. And the third row is also same like two ones are appear, then evens number should be zero, and same fourth one also two, and directly put the zero. So finally we need to count the sum of data bits, like we need to count one and one two ones are appear here, so we directly put it as a zero, and the remaining ones are appear here again. Then again we need to count it here, sorry, zero. Then we need to count it here like a one, and here also one. Then here two ones are appear, then should be directly put the zero because make it as a even. Then in case of here is a one, then directly put and one. So in the outcome of this sums of columns also we need to check once again. Then if it is even number, directly put the zero. So this is the final outcome of each category in the data bits. Like we need to take like this, and like with the zeros. And the third category also given data in which include the zeros as well. And fourth category also given data plus zeros. These redundancy bits are we need to add it at a receiver side. We will check it if the outcome should be in the even numbers at a receiver side. The data should be more reliable. In case of the receiver side gets odd number from the receiver side, the data may be corrupted, or data should be flipped instead of 0 to 1 or 1 to 0. So further, we as a receiver side, we need to give the acknowledgement to the sender side to resend the data for the further communicate for the data processing. So here, as we said, all columns we need to align like that, and we need to calculate the sums and arrange the add the reference bits also. Finally, we need to make it as a even paradites. So at the end of the receiver, at receiver end, these comparison are compared with the parity bits, calculate the receiver data. So the next one is a checksum methods. So checksum method is a quite different when compared to the simple and two-dimensional parity check method. So what is it different? It's like we need to take use arithmetic summations. So here we need to arithmetic summation with ones. So once one means the complementary to further processing to create an error detection code. This is one of the effective method detection random errors in the data segmentation. So how should be calculated? I will explain it here. So first we need to take the two data sets like one and two as a one and two and segment and make it as arithmetic summations. To calculate the arithmetic summation, we need to add it one one 0 0 equal to 0 and 1 plus 0 equal to 0, sorry, 1, and like that one. If then the end of the section, if for example the edge cases, we can see 1 and 1 plus 1 is equal to 0. When you make it a 0, and the remaining should be the 1. So the one should be goes as a complementary here down. Then further we need to make it arithmetic calculations. So again we need to calculate it here. So 1 plus 1 equal to even number 2. So two ones then should be 0. Then remaining one should be appear here. So already one is there. Then we need to add one more. Then should be 0. Then remaining one should be appear here. So like that we need to calculate the arithmetic summations. So once the first category segment is completed, then again we need to take the third segment data should be make it used for the arithmetic summations. So third segment we need to take, and further we need to calculate that one. Then in case of again should be appear one in the addition bits. Then further we go for the complementary. Then we need to add it again. So we need to calculate all the segments like the database like this. The finally will get the sums like that. At the same procedure from the end sender side also, we need to calculate this receiver side without changing anything. We will use the same thing. We take the first two segments of two data bits, two groups of data bits. So ones and two, we need to add it. Again, we need to one is complementary. Then further we need to calculate it. So after getting this receiver side of a sum, it's is this is out at the end of the sum. We need to add it with this one and checksum. So checksum is nothing but we need to flip the data. For example, in case of the result should be the sum of results is we need to flip instead of one we need to put zero and one instead of so zero instead of one and zero one one zero one one like that. We need to flip the data at the sums of end guesses. Then we need to calculate the arithmetic summation again. So if the results all are in 1, then we need to take it as a complement 0 0 0 of all. So like that, the outcome should be like that 0 0 0 0. So if the outcome is 0, the result should be more reliable without any corruption or data losses. The receiver side get the proper results. We need to consider like that one. So this is one of the effective for the detection in detecting random errors in data segments. In case of any bits equal to one, the error should be appeared. The data should be corrected. We can say. So the results finally should be zero. That's all the bits should be the zero. Then it's the data should be more corrected or reliable data. So coming to this, one of the examples here, error detection method using a checksum methods. So examples, the data, if the data units to be transmitted is like the one set of groups and the second set, one subunit and another subunit like that, we need to split it. We need to take it like that. The following procedure is used at the sender side and receiver side also. So we need to take arithmetic summations of subunit 1 and subunit 2. Take it as a sum of these 1 and 2. So if it is even number, we directly put the 0 and 1 remaining, then 0, 0 and 0, 0 and 1. Like that we need to calculate. Then we need to flip. Um, So checksum is nothing but we need to flip the data say here. For example, instead of 0 should be 1, 1 instead of 0 and 0 0 0 like 1 1 1 and 0, 1 1 1 instead of 0 0. So you need to flip the all the data after check. It's the sum of data. This is called a checksum. So in the same procedure we need to execute it in the receiver side also. At the end of the receiver side, we need to add it to the checksum values plus sum of two subunits. So this is the sum of um, checksum plus sums. So we need to count like directly we can count one one one. So even odd number, then so we need to count like one one and remaining should be like one. The or we can directly count from here. So we need to take this one and adding this one. So one and 1, then 1, then here also 1 and here also 1, 1 1 1. So all the categories should be appear like this. So we directly check some complement, like we can directly put it as a 0 instead of 1. So the outcome of the final result should be in the all or 0. It means no error in the receiver side. So coming to the cycle redundancy check method, this is one of the finest method to check the error in this while data transmission method. So this is a powerful error detection technique used in the digital network and storage devices to detect changes or error in the raw data. So it more accurate than the parity check or checksum method because it is a polynomial division in binary model to arithmetics. So CRC. So how we can calculate the CRC, simply called the cycle redundancy check methods, is algebraic polynomial responsible represented as a bit patterns. So here we need to understand how should be polynomial or the key or polynomial divisor should be taken. So n is the number of bits in data to be sent from the sender side, and k is the number of bits in the key obtained from this generated polynomial key. For examples, this is a generated polynomial key given in the while transferring the data. From this generated polynomial key, we will get this proper key to calculate the division purpose. So I will explain. For examples, If the key is given like that means polynomial key, we need to take that initial should this is a constant. We directly put as one and this one and if it is x should be we have to return x over the x x times of x power to the 1 and remaining x to the power 0 and x to the power 3 is equal to 0 and x to the power equal, power 4 equal to 1. So like 1 and 1 remaining 2 in between the two categories should be 0 and final one should be written. So we need to count the number of bits. So total 5 number of bits. So 5 number of bits L minus 1. So I will explain here. Wait. So here we should consider as a this is a generated polynomial key. Based on this key we will call as a L. So based on this L we needed to add it as a end of the section L minus 1. So we need to add a L minus 1 should be number of zeros. So yes, a 4 bits are appeared. So 4 minus 1 3. So for given data plus 3 zero should be added for the division purpose. So employs a polynomial divisions mathematics to generate a highly accurate error detection code. In industry standard for complex error patterns, in case of a kind of high secured or complex kind of data transferring conditions, we will use this kind of method to get the proper data from sender to receiver side. So how the cycle redundancy check method should be work? We need. I will explain first. The cycle redundancy CRC is designed to quickly spot accidental data corruption, such as flipping bits during the transmission or storages of data. It does not provide a cryptographic security. So from the sender side, as senders take a message and applies a predefined generated polynomial key and calculate these reminders. So, for example, the data should be up to this one only, and generated polynomial key, and we need to add it to the three zeros based on the L minus one. We need to calculate the simple division methods, and we need to find the remainder. So, if the remainders from the sender side, we need to take the remainder plus the input data. So, divisor and this is CRC cycle redundancy bit, and we need to add it data plus CRC. From the receiver side, we need to calculate this uh, data plus C remainder and same divisor we have to use it. We need to calculate the same step. If the results of outcome should be in the zero, then the result should be reliable data. There is no corruption has occurred. So at in the transmission is known as a CRC code or checksum is appended to the message and send. So at the receiver side, receiver division. Yeah, I will explain it. So here is a model 2 division. So it's a two binary division methods. Same methods we will use for this method. So like see. This is one of the smart example how we can calculate this cycle redundancy check method in case of no error at the receiver side. So see, this is a given data. So 1000100. So we have to take this given data and given the polynomial key. So x cube plus x square plus constant. So we have to take from this polynomial key as a key point, generator key, polynomial key. So as a divisor, so is a constant we directly take from here, and in between this x to the power 0 and x to the power 1 should be 0. For example, here initially should be 0, x to the power 0 should be, we take it as a 0, and x to the power x square should be 1, and x cube should be as a 1. We have to calculate, take the values from this generated polynomial key. So 1 0 1 1, like that we have to write it. Then we need to add it number of zeros by L minus 1. So 4 minus 1 3. So given data should be up to double zero. Then further we need to add 3 zeros for the further calculations. And we need to calculate the simple division process. We have to use the 1 times of values. So 1101, and we need to devise my simple subtraction process like 1 even number should be 0, and 0 0 equal to 0, and 0 minus 1 should be like sorry here, and 0 and 0, and finally should be the 1. So once again we need to devise the values 1 times of zero values up to, we have to go step by step. We need to take the 0, we need to add it at the end of the section to come count the at the final point. So final reaching point. So the remainder should be the 0 0 1. So once we get the remainder, if we don't have option to further calculation, so this remainder plus the data should be added. For example, see, last three digits should be added with the in this value. So 0, sorry, 1 0 0, the remaining data, input data. So same polynomial key we need to use to further calculation, same division purpose. So we need to division 1 times of values, and go to up to step end of the sections. At the end of the stage, if the value should be in the 0, the from the receiver side it should be the more reliable data, which means there is no correction or any flipping data was occurred. In the second case, here we mentioned as a second case for if it is any error occur at the receiver side. So this is a given data, and polynomial key we need to take from here. So 1, and x to the power 1 should be the 0 because no value is x to the power 1. So we directly put it as a 0, and x square should be 1, and x cube we can take it as a 1. So we need to calculate, and before calculate here we need to add it 0 0 based on this L minus 1, and we have to go up to step by step at the final stage, or no option to further calculations. So the remainder should be 1 0 0 1. So we need to, what we have to do, so the remainder should be added with to the data which we taken for the calculation purpose. So here then we have to calculate further one by one, and the remainder, the outcome or remainders are C or C. If the value should be non-zero, data was corrupted, which means error was occurred. So here how we can calculate the step by step. There is a one more category, like this is a given data and polynomial key. Generated polynomial key, like take it as a 1 1 0, because the x square is not there, so we can put 0, and the x cube is also not there, so we can put 0, and x to the power 4 is here, so we can put 1. So 1 0 0 1 1. So this is a generated key. Based on this, we have to calculate this one. So based on this number of divisor, like bits are appear. So 5 minus 1 should be 4. So given data up to here, we have to add it 4 more zeros at the end of the data bits for the further process. So if the end of the section, if the remainder should be, we got like that 1101 so we have to further add it to the this data at the for last four digits. So which means 0111 should be appear for the further calculations. See, same like another problem also, we have given the data bits we have to take in from here and the generated polynomial key. So key should be 100 and 1. So here, and we need to calculate the CRC at the end of section, then add it to the real values, then further calculate to the receiver side. If the receiver side got the 0, the result should be more reliable. In case of non-zero, error was occurred. So then what you have to do, from the receiver side, need to send the an acknowledgement to the sender side to resend the data to get a real perfect data. So coming to the error correction methods, backward error correction method and forward error correction methods. So backward error correction is nothing but receiver detects a error and requests to resend the retransmit the data from sender side. So once we get the error, once we identify the any error, we have to send the notification or acknowledgement to the sender side to resend the data for getting the accurate data. For the next category, whereas like a forward error correction method, before user renderance bit, user we need to use the renderance bit to automatically fix the error without retransmissions. So where we have to use it, this one like in the real-time application like video streaming and satellite communication purpose, we have to use it like in the renderance bit before sending the data. But in case of backward error correction methods, so like a simplest method and stop and wait while transferring the data and get a more reliable data. So these are some general polynomial key. We have to use it for the generate the key for the division purpose. From this lecture, we will get the outcomes like we will observe the, or we will get the information like increase the data reliability of data and ability to handle the corrupted data in memory and transmissions. And finally, uses redundancy to ensure the data integrity and error correction method as well. Thank you.